Hi folks, in this video I would like to show you how I have modified a swather into a wood processor. There are many old swathers with low hours on the market at reasonable prices. This 5-foot swather has an Isuzu 1.11 liter 3-cylinder diesel engine rated at 28 horsepower, which drives the hydraulic pump. I wasn't sure if there was sufficient oil flow and pressure to split the wood, so I wanted to start with building the splitter before I ventured too deep into the project. I bought a 4.5-inch diameter, 24-inch stroke cylinder from Princess Auto. The cycle time seemed fast enough, so I began fabricating the splitter. I wanted the splitter to have a hydraulic adjustable wedge so I could efficiently split different sizes of logs. I started fabricating a swappable wedge. I wanted a 6-way wedge, but I wasn't sure if there was sufficient pressure to split the larger logs, so I started with a 4-way wedge. You will notice that the wedges are offset, so the system is really only doing one split at a time in the sequence. The knives are made from 0.4-inch steel that I salvaged from an old I-beam. The main wedge is sharpened on both edges, while the secondary wedge is sharpened only on one side. I made some triangular shaped brackets out of 2-inch angle iron to mount the splitter onto the swather. I wanted the cradle to hold the logs while they're being split. The cradle is fabricated from a 1/4-inch plate. It had no trouble splitting 4 ways, so I added more knives to make it split 6 ways. I like the log cradle because once you place the log in it, you can go grab another one while the first log is being split. This really makes the splitting process more efficient. The 6-way wedge is working perfectly. Now that the splitter worked, I turned my attention to make the hydraulic chainsaw. I needed a bar holder, an oiler, and a tightening mechanism. Instead of fabricating one from scratch, I dissected the mechanism from an old Stihl MS290 part saw with an angle grinder. The injection molded piece needed to be flat, so I used my CNC router to manually surface the part. Winter set in, and the cold and snow were making it difficult to work on the project. The unit was too tall to fit into my shop. Every time I used the unit, I had to clear snow from it, and without a cab, the freezing temperatures and wind chill were not very pleasant. Our neighbor had an old parts combine that had a cab. It'd be so good to have a cab on that unit. It seemed to fit perfectly, just like it was made for the unit. The cab sections were easy to disassemble and reassemble as they were modular and they bolt together. You can see the propane heater I used to provide heat while working on the project. The cab was equipped with a blower in the roof to circulate air to keep the operator cooler. A friend had a spare transmission cooler, so I made a wooden box to direct air through the radiator. I tapped into the 2 ports on the water pump, and now I had heat in the cab. The next phase involved fabricating the Infeed trough. I needed chains and sprockets that would have been very expensive to buy new. I bought a New Holland 845 baler for $250. I began salvaging the unit. There are so many useful parts. chains, sprockets, and even the steel plates. I'm thankful to have a plasma cutter as it makes quick work of the project. I needed teeth that would grab the log and move it towards the saw, so I started with a design made of cardboard. I used that cardboard to draft a design. The flat profile in the middle of the teeth is important as it allows the chain assembly to slide on a flat iron under the infeed to provide clearance for the mount on the swather. I had several sections of rectangular tubing that came from metal shelving. It was pretty thin-walled material, but when welded together, it made a fairly sturdy infeed table. I used some 1/8" plate from the baler sides making this infeed. I fabricated some gussets from the 1/8" plate to provide more strength for the sides. I mounted the infeed assembly on the swather. The infeed is 16 feet long and sticks out more than the splitter assembly, so it helps distribute the weight better on the swather. I was pretty delighted to have the infeed functional. The next phase was to get the hydraulic saw operating. I wasn't sure if the 0.517 cubic inch hydraulic motor would have had sufficient power to cut the logs, but it worked. This is the first trial of the hydraulic saw and tipper table. The saw gets lifted by a hydraulic cylinder but lowered using gravity. If you look closely, you will see a series of lead blocks on a chain. I didn't want the saw assembly lowered with hydraulics, as I would need a pressure regulator to ensure that I did not damage the saw assembly. You will also see a crude mounted oil reservoir on top of the saw assembly at this stage. The processor worked well, but needed to have a log dispenser so 6 or 7 logs could be loaded onto the rack. This saves me going back and forth between the skid steer and the processor. The rack is 12 feet wide. It used the floor chains and sprockets from the baler. I used a 4-spool valve assembly as there were not enough valves on the swather for the various operations. I mounted a solar panel and charge controller on the cab to keep the battery in a charged state. I moved the gravity-fed oil reservoir down and used an inexpensive fuel pump attached to the bar oiler. There is a switch assembly next to the hydraulic clamp that holds the log. As the clamp hydraulic cylinder is in parallel with the chainsaw lifting cylinder, the oil pump is only activated when the log clamping and cutting is active. This is a view of the hydraulic motor which drives the log rack chains. There is a 3-to-1 reduction using the 2 sprockets. The large sprocket is attached to a 5-to-1 reduction box that came from an old elevator that used a hand crank in the event that you were stuck in the elevator. The reduction mechanism would not be necessary with the proper hydraulic motor. I used one of the hydraulic motors from the swather reels that did not have much torque. I used 4 jacks on the corners of the log table as it allows height adjustment to perfectly meet the infeed table and does not require the ground to be level. You will also see 2 jacks, one on either side of the infeed table that provides stability, as well as it takes the load off the small swather. If you look carefully, you'll see some red and blue paint marks on the infeed. The reds are 16 inches apart and the blues are 20 inches. This allows me to keep the logs consistent in length as I have a visual reference as I advance the logs on the infeed. I've invested in some surplus IBC containers as it allows me to stack the wood in them. The split logs dry quick as there is lots of air circulation. The plastic liner can be split to form covers for the containers. When I'm ready to use the wood, I can move them next to my wood gasification boiler with my skid steer, which saves me many trips to the woodshed. Thank you for watching. I hope this video has provided you with some information to build your own processor. I'll be making other videos, so please subscribe. Take care.